Hello everyone. Our task for today is to determine the presence of ethanol in a hand sanitizer sample with the aid of gas chromatography. We are given the GC chromatogram of ethanol standard and the GC chromatogram for the hand sanitizer sample. Now, what is gas chromatography? Gas chromatography is a common chromatography technique that is used in analytical chemistry for separating and analyzing compounds that can be vaporized without decomposition. The compounds are separated based on their volatility. Typically, the mobile phase used is a gas that does not interact with the analyte, like helium, hydrogen, or nitrogen.
We will look at the methodology for gas chromatography, beginning with sample preparation, where a GC vial is filled to the predetermined mark with a low boiling point solvent, such as methanol, diethyl ether, or acetone. Then, one drop of the sample to be analyzed is placed into the vial using a dropper. The vial is then capped and inverted several times to dissolve the sample. The sample is now ready to be injected into the gas chromatograph. The sample injection involves taking a small amount of the liquid sample to be analyzed into a syringe and then injecting it quickly into the hot injection port of the gas chromatograph. The time of the injection is taken as the beginning of the retention time of the analyte. Thus, injection must be done swiftly. Afterwards, the temperature of the pot is raised to be higher than that of the boiling point of the analyte, so they will vaporize. The vaporized analytes then mix with the inert mobile phase to be carried to the gas chromatography column, where separation will occur. During the separation process, the components in the sample separate based on their adsorption rate to the stationary phase, according to their polarity. Components that adsorb strongly will stay in the column for a longer period and have a longer retention time. The inverse is then true for components with lower absorption rate. After the analytes have been separated and exited the column, the detector will detect them, and individual components of the sample appear as different peaks in the chart. These peaks are due to the components reaching the detector at different rates due to the differing times they are retained in the column. Each peak on the GC chromatogram can be cross-referenced with a known standard to identify the chemical species.
Based on the result of GC chromatogram of ethanol standard, we can see that only one peak that present in the chromatogram, which is at 5.08. So, we can consider the peak as the ethanol retention time because only ethanol compound is present in the ethanol standard. While in the result of GC chromatogram for hand sanitizer AA, we can see that there are 4 peaks that can be analyzed, which is at 5.08, 18.51, 19.23, and the last one 22.65.
In this experiment, the task that we need to do is determining the presence of ethanol in hand sanitizer sample by using gas chromatography. Gas chromatography is one of the best methods to run this experiment because ethanol is a volatile compound. By using the gas chromatography method, the volatile compound of interest can be primarily separated based on the boiling point. In addition, the GC column with polar selectivity also can provide additional intermolecular interaction like dipole interaction to separate the individual components according to their polarity. After running the experiment, we will get the chromatogram, which is the result of gas chromatography. The peaks that have been generated and shown correspond to the time indicate each component reached the detector. In this experiment, the hand sanitizer is used as a sample and ethanol as analyte. The presence of ethanol can be detected using the retention time from the chromatogram. The retention time of unknown substances can be compared with the retention time of ethanol, and if both of them have the same retention time, it indicates that the ethanol is present. So, after comparing these two retention times, we found that both retention times are the same at 5.08. So, this proves that ethanol is present in the hand sanitizer sample.
After we analyze both chromatograms, we can conclude that the ethanol retention time based on the ethanol standard chromatograms is 5.08, and the same ethanol is also present in the hand sanitizer AA. So, hand sanitizer AA can be used as hand sanitizer because it meets the correct formulas as suggested by WHO.